I'm going to briefly explain what is support vector machine. Both logistic regression and support vector machine are supervised ways to classify data. Both logistic regression and support vector machine involve binary classification of dependent variable. In other words, the dependent variable in our analysis has two categories. Even though in the case of support vector machine, the dependent variable can be extended to more than two categories. These two techniques are supervised approach to classify data because we often separate our data into a training component and a testing component. We use the training component to model our data, and we use the testing component to assess the performance of our training component. Both logistic regression and support vector machine are supervised ways to classify data because we pre-specify the independent and dependent variables to be used in our analysis. So, here are the list of independent variables I would like to use in my analysis. In this case, the dependent variable would be the probability of loan staying current in a given time period. Even though they are both supervised ways to classify data, support vector machine can be distinctively different from the logistic regression. The logistic regression uses the maximum likelihood estimation to find the parameters that best fit our observed data. The support vector machine uses the hyperplanes as decision boundaries to classify data. The best hyperplane often maximizes the margins. You can think of the margins as a line or something non-linear that classifies our data into different groups. For the case of support vector machine, this technique can also be used when the data cannot be separated by a linear boundary. And I will show you what I mean by that. So, these are what hyperplanes looks like. When we have two variables, our hyperplane looks something like a two-dimensional space. And in this case, a linear line can be used to separate the data, but this is not always the case. When we have three variables, our hyperplane looks something like a three-dimensional space. And here, we use a hyperplane to separate our data into different groups. And for human beings, I think we can observe at most three-dimensional data. And for some people, in rare cases, a few of them can imagine or observe four-dimensional data. But those are rare cases. Sometimes our hyperplane may be more complicated, even though this is still a three-dimensional data. In this case, three variables. We can twist and turn and whatnot to our hyperplanes when we classify our data. So, this is how support vector machine is different from logistic regression. Hyperplanes are used as decision boundaries to separate data, to classify data into different groups. And sometimes hyperplanes can look like this, can be something very complex. We can bend, we can twist and turn a hyperplane in our attempt to classify or separate our data into different groups. And as I mentioned here, support vector machine can also be used when our data is not linearly separable. And this is what I mean here, that our data is not linearly separable. You can see that the black dots and the red triangles, they cannot be separated by a straight line. They are scattered everywhere, even though they are classified into different groups, but they are scattered. And this is what we mean by a non-linear classification boundary. And this is another different portrayal of a non-linear classification boundary, even though the data comes from the same source. As I mentioned earlier, we human beings, we can observe at most 3 dimensions, and because of that, I just picked 2 independent variables at random from this list to depict what I mean by non-linear classification boundary, because it's hard to visualize more than 3 dimensions. As you can see from here, we have more than 3 independent variables. But to simplify things, to illustrate what we mean by non-linear classification boundary, I just picked 2 variables at random to show you what I mean by non-linear classification boundary. This is a case where our data cannot be separated by a straight line. In other words, our data is not linearly separable. This is another depiction of non-linear classification boundary. You see a bunch of X and zeros in this diagram here, and some X's are colored in black, some X's are in red, some O's are in black, some O's are in red. And the colors depict the different classification of data. And the X are the support vectors. The support vectors directly influence the classification. So this is very different from logistic regression that uses the maximum likelihood estimation to look for parameters that best fit the data we observe. And the support vectors demarcated by X, whether it's red or black, has more influence, carries more weight when we attempt to predict if an observation belongs to a particular group. And the 2 groups are represented by the 2 different colors here. And those points demarcated by O, they are not the support vectors, and they do not influence the classification.